Rosen. Well, I know we're both beyond use. Don't make no.
Alright, here's number 2. We're going to evaluate g of f of 5. And we're given a table here. First of all, this table is a little bit confusing, but all it means is that this x is basically representing our input for any of these functions. This is f when you plug in your input, and this is g. Okay? So in order to figure out g of f of 5, we're going to start from the inside and work outside. So that means our initial input is going to be a 5. So what we have to figure out first is what is f of 5. Okay? So f of 5 is going to be equal to, let's look at our table. So when we input 5 into f, so we're at 5, we get, from f, we get a 0. Okay, so f of 5 is equal to 0. Alright, so that means we can replace that, the inside here, with a 0. And that is a really weird 0. 0, there we go. So now we're just looking for what is g of 0. And this is going to be equal to, when we input 0, for g, we get a 9. Okay, so 9 is going to end up being our answer. 9 is equal to g of 0, which is also equal to g of f of 5. Okay? Okay, problem number 3 asks us to use the graphs below to evaluate the expression g of f of 1. Okay, so here our initial input value is going to be a 1, and it's first being inputted into the function f. Okay, so we need to figure out what is f of 1. So let's look at our graph. So this is our f graph over here. So when we have an input of 1, which means input of 1 on our x, then the value of our function is going to be, let's see, and that would be 3, right? So f of 1 is equal to 3. So that means we can replace that inside with just a 3. So we're looking for g of 3 now, and then that'll give us our answer. So let's look at this other graph. So when we input a 3 into our g, we get an output of, and this value of the function would be a 4, right? So g of 3 is equal to 4, so that means that overall g of f of 1 is equal to a 4. Okay, number 4, we're told to find f of g of x and g of f of x. And we're given the formulas for f and g respectively. Okay, so here what we're doing is working with formulas in order to create that individual or singular composition of functions, all wrapped into one function, okay? Kind of to eliminate this whole like back and forth between two different functions. So let's do the first one. So we have f of g of x. So what this means is that into our outer function, into our f, we're just going to plug in the entire g of x, okay? So let's look at that. So we have the input being g of x. So that means that whatever for our f of x, so here's our f of x function, right? So this represents our input here, this x. So whatever we have for our input is going into this spot, okay? So if our input is g of x, that means that g of x has to be in that spot, which is being squared. And then we add 1 to it, okay? So now what we have to do is say, okay, well, g of x, we have to think of something more specific than that. And we do have extra information that we're given, right? That g of x can be represented by this formula here, which is square root of x plus 2. So we're just going to plug that into our g of x spot, okay? So this is going to be in parentheses. We can put in the square root of x plus 2, and then being squared, plus 1. Alrighty? So if we continue simplifying here, we see that actually, very conveniently, the square root and the squared cancel. Okay, those powers cancel, so we get x plus 2 plus 1, which ultimately ends up being an x plus 3, right? That looks more aesthetic and easier to deal with than trying to, if you were to find like f of g of 1 per se, then plugging in 1 into g and then plugging that result into f. So here we could just plug in a 1 directly and just get an answer of 4, for example. Okay? So now let's do the other part. We're going to do the other way. So g of f of x, we're going to do the other way. So f of x, that whole f function, is the input to g. Okay? So wherever we see our input, so here's our input g, right? That's represented by an x. We're just going to put the input right in there inside the square root. So we have square root something plus 2, and our input is now our f of x. F of x. That's in our input spot. Okay? So now we're going to write in, instead of this f of x, we're going to write in the actual formula for it. So that's going to give us the following. So we have square root of, in parentheses, x squared plus 1, and then plus a 2. Okay, so this x squared plus 1, we just replaced our f of x with that x squared plus 1, because that's the formula we were given. Okay, So then this is going to reduce to, so we just simplify everything on the inside. So we're just going to get the square root of x squared plus 1 plus 2, which is equal to a plus 3. Okay? And that's basically it. This is our g of f of x. That's our single function which represents the composition of g and f.